Well, good morning, everybody, and welcome to Ellensburg, Washington, USA. Saturday morning, very quiet on campus. In the 30s Fahrenheit, looks like it's going to be 40 degrees plus for the next week. Looking forward to being outside more than I have been for the last few months. And maybe you have that feeling too if you're up here in the Northern Hemisphere, dealing with winter conditions. So nothing to complain about here for sure. The local time is 8:48, I guess, maybe 8:49, and we will begin our program in about 10 minutes at the top of the hour. That's 9 o'clock Pacific time, as is the custom here at Baja BC headquarters. What? Are we functional? I see some 5x5s. Thank you for that. Grab my hot cup of water, courtesy of Kirk and Philomath. Thanks again for the mugs, Kirk. Snarky user has always got that hat icon. Snarky, I don't know what that's about, but it's always kind of fun to see that. Edmonds, Washington, good morning. Boise, Idaho. Bergen, Norway. Butler, Missouri. Pittsburgh, Pennsylvania. Madison, Wisconsin. West Allis, Wisconsin. Calgary, Alberta. Scrolling too fast. Let me go back a ways here now. Come on. Edmonds, did I just say that? Yeah, I think I did. Hollister, California. Pittsburgh, Pennsylvania. Long Island. Hello, Robert. That's in New York, I presume. Dayton, Ohio. Unity, Wisconsin. Oh my God, we got a lot of Badgers here. Cretaceous, Texas. Half Moon Bay, California. Manteca, California. Hello, Peter. Indiana. North Okanagan, British Columbia. Hello, Mary Ellen. I'm not sure I've seen your name before. Cleveland, Ohio. Leamington Spa, UK. That's Mark. Glen Haven, Colorado. Sulphur, Oklahoma. Red Deer, Alberta. Spokane, Washington. Sequim, Washington. Cincinnati, Ohio. Elma, Washington. Estacada, Oregon. Hello, Mr. Tony, 19. Houston, Texas. Down to live against my greater judgment. Coos Bay, Oregon. We're talking about your home turf here today, Sharon. Thanks for joining us. And Jay is in Netards, Oregon. That's on the coast as well. Maybe the northern Oregon coast. Portland, Oregon. The Chuckanut. That's Ian. The Villages, Florida. That's John. Don is checking in from Fairbanks, Alaska. Chicago, Illinois, that's Andy. Michael's in Republic, Washington. David is in wonderful Fairwood, Washington. I don't know where that is, David. Where's Fairwood, Washington? Never heard of it. Keyser, Oregon, that's Ann. Sonora, California. Hello, Marcia. Good morning. And so on. Great Falls, Montana. Vancouver, BC, that's Matt. Renee is in Quebec. Okay, good. Well, let me email our guests. I have two of them this morning. So let's do the copying the link and pasting the link trick and converting it to plain text, because that's how I roll. And this is going to both Ericka and Rich in New England, in Massachusetts, from Gmail. All right, well, presumably that's on its way to those guys, and presumably both Ericka and Rich will show up in the green room in just a second. Let me do a couple of scheduling things quick, so it appears that we're 5x5 and we're doing okay. It's almost like I don't need to do this anymore, but I feel like I need to for those that need reminders. Here we are on Saturday morning, February 4th. And we will continue with the alphabet. Next time I see you will be Wednesday, February 8th at 2 p.m. And we have a handful of shows left. But some of you know, some of you most loyal people know that I also occasionally do broadcasts live from the room here, same room, on Fridays at noon. And it's been a couple of weeks where we have not had a Friday at noon talk. but one is coming up this coming Friday. So I wanted to just make sure that you knew about it. Friday, February 10th. So that's this coming Friday. Friday, February 10th. We will hear about 200 years of women in the field, contributions and controversy in geology. And both Lisa and Ann work with me here in the geology department. And then we'll take another Friday off, and then we'll have 2 more Fridays to round out the spring quarter here at CWU. So if you want to make a mental note or a physical note that this coming Friday, I'll remind you about this again on Wednesday, but 6 days from now, we'll have a special noon talk from Lisa and Ann. Okay, those are the scheduling reminders. Oh, I see Ericka's in the green room. Hello, Ericka. Can you hear me? Okay, you're waving. That's wonderful. And there's Rich. Okay. Good morning, Rich. Can you hear me? Can you? Okay, wonderful. Terrific. Well, A+ effort by both of you guys to get here without a problem. That's terrific. Full disclosure, I have to tell everybody, I texted both of these guys, or no, I emailed both of our guests today and said, I just got an email that the campus email server is going to be down on Saturday morning. And they're hopefully going to be done by 8 o'clock local time. So it's like, oh, great. So I got the cell numbers for both of these guys in case we didn't have internet, but we're good. We're good. So that's one less thing to be concerned about this morning. I'm not concerned about anything this morning, to be honest. I met our guests for the first time the other day and thoroughly enjoyed visiting with them as we tested the audio and visual. So I'm looking forward to a pleasant and stimulating morning, and I hope that you are too. We have about 500 with us at the moment. More continue to trickle in. Rachel says, thanks for the Friday schedule update. Oh, you're welcome, Rachel. Yeah, it's been a couple weeks since we've taken a couple Fridays off from that department talk series. And I'm proud to report that it's been such a big part of people's weekly schedule here that everybody's like, well, who's talking on Friday? I'm like, well, we're taking a couple weeks off. They're like, what? Oh, okay. Even Jeff at Vindman's is like, I'll see you Friday with some stuff. I'm like, no, you won't. We don't have a talk. I'm talking about yesterday. And the main reason I didn't schedule 2 Fridays in a row is because Hannah Shamloo and Jordan Carey are in New Zealand, and they are big parts of the scene here now. These young folks, these young professors we're building around them, and we're very excited about them here. And so, why have a party if we don't have the stars of the party, Jordan and Hannah? Okay. Couple more hellos, but I'm feeling like we're up and running. The guests are ready to go. Guests, I'm thinking 10-15 minutes on the chalkboard. Then I think I'll bring in Ericka first. Talk to Ericka for a little while, and then we'll bring in Rich. Hope you're okay with that, Rich. All right. So yeah, how about where are you from? And say hello to a few more of you before I have to start concentrating about today's show. Really looking forward to today. Gary is in Saraland, Alabama. That's a new place for me. Thank you. Shannon's in New Mexico. Finland, good morning. Germany, good morning, or good evening, I guess. Andre. Dallas, Texas. Woodinville, Washington. Fair Oaks, California. Waikele, Hawaii. Haven't seen Randy Lewis in a while. I do text with him regularly, but I'm looking forward to connecting with Randy this spring. Bo's in Denmark. Therese is in the Netherlands. Speaking of which, it looks like Nora Lee from Itchy Boots, favorite YouTube channel of mine and many of yours, is back on her motorcycle and filming again for her next season. A total secret where she is. But I just had this thought this morning. I was thinking about her. So she was just wrapping up her Alaska series about the time we were starting this series. And now I'm about to wrap up this series, and she's about to start posting again from her next season. So it's almost like we coordinated that, but I don't know, Nora Lee. We emailed a little bit back and forth during the pandemic just because it was such a weird time, but she's got a much bigger scene now, and I'm sure cannot keep up with emails and things. All I'm saying is that when we close up this series, there'll be probably Norley to continue with, although I don't know exactly when she's going to start posting. 3 or 4 more highs, and then I'm going to start concentrating here. Bertha, Washington. Never heard of that either. Renton, Washington. Stockton, California. Bellevue, Idaho. Oh, everybody's talking about Norley now. Oh, yeah, man. Mike is guessing she's in Australia. That's maybe my guess too, Mike, but I'm not sure. Des Moines, Iowa. Hey, come on now. Russia? Veliki Novgorod. Hello. I'm not sure you've been with us before, and if you have, I haven't noticed you. That's a thrill. I'm not sure we've had many Russians with us. I'm very excited about that. So thank you for being with us today. Okay, it's almost 9. Give me 2 minutes, would you? I need to concentrate, and then we will begin our program on the Gold Beach terrain and possibly other topics as well. Thank you. Hot mic. Hot mic. Hot mic. Okay, you're setting up our guests as usual, but you're doing it in a way where you're just being really open-ended, right? You're asking a lot of questions just in general, not really to our guests. You're just asking questions because you're confused. It's okay to be confused. That doesn't show weakness. You're just confused. That's okay. You're going to talk about what you're confused by and where you think there might be some interesting nuggets, no pun intended, with not only today's terrain, but others down there. Okay, that's what you're going to do. You're not going to the laptop. Yeah. You're going to share what you're confused by. Weird way to start, but I think it'll work. You listening to me, boy? Yeah. Okay. That might work. Why not? Try it. Try it. It might work. I think it might work. I think it might work. Well, a pleasant good morning to you all. It's Saturday morning here at Central Washington University. I'm alone in this large auditorium, room 103 in Discovery Hall, as is the case every time I'm with you. We continue the series, and after the last couple of shows where our scope was incredibly large, Mexico up to Alaska, we are zeroing in today on a particular place. And I'm confused by the place. I'm confused by the Klamath Mountains in southwestern Oregon. And you're like, okay, Gold Beach terrain. I guess we're going to the Klamath. Well, until our guest started sending a few papers and Ericka sent her master's thesis to me, this is like 4 days ago. I assumed I was going to be learning about the Klamath. I'm not sure I am. That's the first point. The Gold Beach terrain, much to my surprise, is in the Franciscan complex. And for me, as a Geology 101 instructor for many, many years, I've taught about the Franciscan complex as a California story. And without knowing it, I was teaching the conventional story about the Franciscan complex. But we're not going to California today. We're going to southwestern Oregon, and yet we're talking about the Franciscan complex, and not the entire Franciscan complex, but just one of the slices within a very complicated Franciscan complex. So this is new to me. And that's the flavor of today's episode, I hope, that I'm going to set up our guest just by saying, here are the scraps of things that I think I've heard. And Basil Tikoff was with us the first Wednesday of the year, right after the holidays, January, last month, last month, whatever it was, January 5th, I guess, 4th. And I asked Basil about the Klamath, and he's like, oh boy, there's a lot going on with the Klamath. And so I have questions. I don't know how many of my questions are going to be addressed specifically today, but I'll just throw some stuff out. We'll see where we go. And I think there's also a chance we're going to end up in Idaho today because Rich Gaschnig is best known for his work on the Idaho Batholith, which seems like a total departure from our topic today, the Gold Beach terrain, but I wonder if it is. Okay, so that's my introduction to my introduction. Huh? Weird. Okay. So Franciscan complex, what have I taught for many years? This is going to go quick. The California Triad. Now we're going back to Darrell Cowan, session B of this current alphabet series. And the Franciscan complex is in green here. It's this incredibly complicated accretionary wedge, subduction complex, all sorts of names for this collection of generally oceanic material on the coastline of California. And this Franciscan complex is number one in the state of California, the California Triad. I'm reminding you of the most basic message about California geology. And the most basic conventional message is we have eastward subduction of a Farallon plate starting 200 million years ago and having this steady subduction of the oceanic Farallon plate. That's this guy here, right? And the California Triad, the Franciscan complex, the Great Valley sequence, a four-arc basin, and then the Sierra Nevada volcanic arc through much of the Mesozoic and continuing even into the Cenozoic is the story here. California Triad, very simple California geology. Any questions? No? Okay, we're moving on to some other lecture in Geology 101. Okay. Pause for dramatic effect. The Gold Beach terrain is up here. I've got a separate map coming in just a second. It's in southwestern Oregon. And the Franciscan complex is not just down here in central California, tied to the Sierra Nevada volcanic arc. The Franciscan continues and narrows down up by Crescent City and then fattens back out a little bit into southwestern Oregon, and it skirts next to the Klamath. And the Franciscan complex, this stuff, is geologically and geographically separate from the Klamath. Okay. So I'm like taking California geology mentally and bringing it north. I'm kind of puzzled as I go. Like, why is this up here, but not the rest of this stuff coming up here? Let's go to another chalkboard. Oh, by the way, we're going to get down to detrital minerals again today. It's been a while. You remember we had four separate shows before the holidays in December with Danny Coots up in Calgary, Will Matthews up in Calgary. They were looking at detrital zircons. Jerome Lessman was talking about detrital zircons. Brian Mahoney, Paul Link, detrital zircons. I thought also that Ericka and Rich were looking at detrital zircons within the Gold Beach terrain, but they're not confined to detrital zircons. As I'm reading, and maybe you've read as well with the papers assigned to today, Ericka's thesis, they're looking at other detrital minerals as well within the Gold Beach terrain. So we're down to teeny tiny details in a terrain that potentially have regional importance. Okay. So I spent a little time in here last night. Had a little fun. Here's my main questions, all in the name of setting up our guest today, all in the name of setting up our discussion with Ericka first, and then we bring in Rich as well. We're going in the neighborhood of the Klamath Mountains, but we're going to Gold Beach. There's a town called Gold Beach, and there's a sliver of Franciscan complex that is called the Gold Beach Terrane. We're not in the Klamath proper. We're in this little strip of California coast north of Eureka, California coast in the neighborhood of Gold Beach, Oregon, Southwest Oregon, and we're going to be doing our detailed work right here. But before we lose this map, I'm confused about, I continue to be confused. I mean, ask Basil, ask others. I read different roadside geology guides. I read scientific papers that are detailed. Can I or can I not connect the Klamath with the blues? And our guest today might not be wanting to get into that. They might. So yes, we're going to look at the Franciscan and the regional implications and the potential excitement with Baja BC with the Gold Beach Terrane. But right next door is the Klamath, and I think our guests today are going to say there's details in the Gold Beach Terrane that really have nothing to do with the Klamath. So you can see why they wouldn't want to talk about the Klamath that much, because they're saying that this stuff has got nothing to do with the Klamath. And yet, are the Klamaths intermontane? I thought I learned pretty firmly from Basil Tikoff and Bernie Housen in the brand new paper, 2023, Hit and Run, that the Blue Mountains of northeastern Oregon are intermontane. And whether you're willing to go down to the level of detail to say that this is Stikine and Cache Creek and Quinella, I don't know if we need to go that far, but is this intermontane in Hell's Canyon? Is this intermontane firmly up against the western Idaho shear zone? Yes or no? I think Basil's saying yes. Well, I see all sorts of maps from Todd Lemaskin and others and roadside books that swing the geology of the Blue Mountains in northeastern Oregon, and we connect the dots between the blues and the Klamath and say this is the same stuff. If that is, and if Basil's so sure this is intermontane, can't I just say the Klamaths are intermontane? Well, maybe I can. But then again, I went back and rewatched the Basil show, and I'm pretty sure Basil said south of the Klamaths there's no intermontane. And yet I see maps that take the Klamath geology, boom, 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 and swing it across to the foothills of the Sierra. Not the Batholith now, but the foothills of the Sierra, the wall rock that the Sierra Nevada Batholith is intruding, the foothills of the Sierra. And I see a continuation there as well. So if this is intermontane, and you correlate here, that's intermontane, why wouldn't you call this intermontane as well? And who gives a shit? What's the payoff for that? Well, here's why I think it's important. What do I know? I'm at Central Cow Pie State, you know. It doesn't matter what I think, but I'm trying to find narratives and plug some of this into some of these regional discussions we've been talking about. Here's Mappy McMap. I think I'm hearing from many people that Quinella, Cache Creek, and Stikine are intermontane. We can all agree on that. And that the majority of intermontane is up here in BC. And I think one of the main things I learned from Basil is that the blues are like a leftover piece of intermontane. Like most of intermontane, if you want to think of it as a whale, most of intermontane went north younger than 100 million years ago, and there's just a leftover piece of it down here. And I think he mentioned this piece as well, a little piece of Quinella down here. So we have scraps of the whale that got left behind. We knock off a couple pieces of the whale, keep them down south, whereas most of the whale, the intermontane whale, is north. I think that I'm hearing that the Gold Beach Terrane, which isn't even on this map, this is me 2 years ago ignoring the Gold Beach Terrane. I think I'm hearing from Ericka's thesis that the Gold Beach Terrane is a leftover piece of insular. So we're back to two separate whales, thinking about that, at least for today's show, Intermontane, that's one whale. Insular, that's another whale. Do we have leftover pieces of both whales further south, whereas most of the whales are up in British Columbia? And how much of both of those whales were in Mexico originally? So I'm confused. I think it's a good confused. What? But I'm confused. Can I help you see why? This is the last thing I'm doing before we go to Ericka. Let me show you why it was a struggle for me just to get to those questions. That's a weird thing to say. It's like a struggle to get to some questions. Yeah. I think I need to like write a bunch of stuff out, get a bunch of these scraps of names and everything, look at them all, rearrange the pieces of paper until I can kind of come up with at least a few interesting questions. To me, those are interesting questions, even though they're confusing at the moment. And maybe we'll never find the answers to those before Z. But if I can keep this on screen, I want to keep, Klamath and the Sierra on screen. I'll cover it up for a second just to show you this. Going through Ericka's thesis, going through other papers, here's what you're faced with when you're trying to learn some brand new stuff in an area that's brand new to you. And yeah, this area is essentially brand new to me. You can see why you just want to leave, right? So in extreme southwestern Oregon, along the coast, near Gold Beach, Oregon, we have the Franciscan complex. I'll show you some stuff on my laptop after we visit with Ericka and Rich, but I think Ericka has some slides for us as well. And here's the Gold Beach terrain that we have right at the coast. And we're going to Ericka in just a second. She's going to tell us in detail about her work with the Gold Beach terrain. But there's these units as well. Each of these is a terrain within the Franciscan complex that appear to be distinctively different than the Gold Beach. And so I think one of the main messages of today is, do we have a major Baja BC type fault within the Franciscan complex? And if we like that idea, then we better have significant differences between Gold Beach terrain and the rest of the Franciscan to say that the Gold Beach terrain went north compared to the rest of the Franciscan, just let alone that. But then if we go inland and try to make any connections at all between stuff in the Klamath, you just saw where they were. It's basically like if we have a bunch of minerals, detrital minerals at the coast by Gold Beach, aren't you thinking that the rivers are just bringing a bunch of minerals, detrital stuff from the eroding Klamath? Yes or no? And if no, then there's a story. If yes, then there's not much of a story, I guess. You're just eroding stuff out of the interior and bringing it to the coast. But these guys, just in the Klamath, look at the different terrains, including the Josephine ophiolite that I keep hearing about, because my old friend, the Ingalls serpentinite, 162 million years old, from right over there north of my town, the Ingalls ophiolite, 162 million years old, I keep reading and keep hearing that is the same exact stuff as the Josephine. But the entire Klamaths are not the Josephine. The Klamaths are split into 3 separate units as well. And again, this is the idea. Are these 3 units correlative up to the Blue Mountains? And can we also bring those 3 units and bring them down to the Sierra foothills? I mean, this is energizing, fun for me to learn some new things and try to plug them into some of these concepts and these themes that we've been working on all winter. Ericka, I'm coming to you. We're going to go to Lowell, Massachusetts for both of our guests. And let's see if we have luck finding Ericka first in Lowell, Massachusetts. Good morning or good afternoon, Ericka.
Hi, Nick. How's it going?
It's going great. Boy, you're looking good and you're sounding great as well. Video and audio is working perfect on your end. How are you feeling from your side?
Yeah, everything's good.
Okay, good. Well, thank you for being with us today. I guess it's a little bit after high noon there. Would you mind sharing some of your story, first of all, before we get into the details of the Gold Beach terrain? Did you grow up in New England, and how did you find geology?
Yeah, I did grow up in New England. I've been here my whole life. And I actually live very close to the University of Lowell. So it was kind of like, okay, here you go. But my education has taken a very long time. So I have two kids that are 8 and 10. So I was only going to the university part-time when they were little. And then I kind of accelerated everything sort of after they got into school. So I just finished my master's this past summer. And now I'm starting the new PhD program that UMass Lowell has with Staying with Rich.
Staying with Rich and starting a PhD. Well, we definitely want to hear about that too. A couple more personal questions, if you don't mind. So some of my favorite students here have been returning students, folks who just don't go to college right away, or if they do start college for a year or two and then get into busy with life and everything, and then they come back and they are so motivated and just laser focused, and they're just hungry to get back into this world. How much of that applies to you as well? Did you go to college right out of high school and then stop for a while?
I was actually a massage therapist for 2 years when the kids were very little, and that's how I was making my money. But yeah, I got into geology specifically after starting at UMass Lowell, and I was originally a biology student, but they gear it towards the medical side of things at UMass Lowell, so I was not interested in that. And I talked to a professor in the environmental department and fell in love.
Great. One more, and then I promise we're getting to your study.
No problem.
I was intrigued just by your acknowledgments in the thesis, and you shared that with us, so everybody can kind of read the entire thesis, including I'm guilty of the same thing. I'm like sharing some rather personal stuff in the kind of dedication or the acknowledgement part of the thesis. You said something like, "I'd like to thank Rich, my advisor, for introducing me to the field," essentially, or you really hadn't been out in the field much at all. Would you comment on that, like being introduced to the American West really for the first time, basically?
Yeah, so I had been into the Southwest before, but not for geology purposes. But in December 2019, Rich took me out to Oregon, and I actually got to collect my own samples. So that was like a huge thing for me. Seeing these really big processes that was only in my textbooks come to life was a very emotional experience for me.
I can relate to that. And yes, it's in living color. You're breathing it, you're feeling it. And that maybe sets us apart from other studies. I don't know, but that's a big part of this. And I'm glad that you experienced in that. And will you be doing more field work for your PhD?
So this past summer, we were actually in Montana and Idaho collecting in Idaho collecting samples, but it was a little mini field camp for some of the undergraduate students. So the last 5 days of that, Rich and I spent in the Idaho wilderness with Reed Lewis and one of his students.
Oh, good. Okay. Well, thank you for doing that. I feel like that's often overlooked in these kinds of talks. Like people just kind of the excitement, much of it's new. I can go on and on. I guess I won't. So let's bring in Rich, hear a little bit about his role with you as well as his academic work, and then we'll get into the Gold Beach stuff, I promise. Okay, so thanks for that, Ericka. Here comes Rich. Good morning, Rich. How are you?
Fine. Thanks for having me.
It's a blast to have you here. Thank you. I know your name, Rich. I think we met once at a conference a few years ago, but I know your name from your work with the Idaho Batholith. Can you comment on why you started studying the Idaho Batholith? When did you? And and how many years were you at it with the Idaho Batholith, or are you still working on it?
Yeah, I am.
All right. Well, Ericka, can you hear me?
Yeah, I can hear you. Rich, we can't hear you.
Not sure what happened. We had you, Rich. Let's
Hello?
Oh, yeah. Got you now.
Yeah,
look at this guy.
I was trying my wife's fancier webcam just because it gives a better angle. The one on my laptop, it's like at the bottom.
Okay.
But we might as well just use that since you're going to hear me now.
Oh, that's good. Oh, man. Well, you're quick on the draw, man. I'm impressed. Like that was a quick change. Good for you. You heard my question. Why were you studying the Idaho Batholith, and when did you start doing that work?
Yes. So, okay. So I got my master's at the University of North Carolina, and I was working in the Sierra Nevada, so another big batholith.
Yeah.
And I kind of didn't know what I wanted to do going into grad school. Like I was interested in like tectonics, and I kind of got set up with a structure project that was in the Sierras, looking like not at the granites per se, but like just looking for structures in the granites. But I found working on them that I kind of fell in love with igneous rocks and granites in particular. And realized I didn't really like structural geology very much. So I ended up doing some dating for that work, zircon stuff. And then I was just looking for PhD programs to apply to. And so, I was looking for places where I could do more like granite stuff. And also I had become really interested in detrital provenance stuff at the same time, just because there are students in that department that were doing detrital zircons. And I thought it was like the coolest thing that you could like look at sand grains and basically say, where did it come from? Right. And so that was like something I was also looking at for like PhD work too. And I almost went to University of Florida to do a provenance project, but it kind of fell through. So Washington State is where I ended up, and that was to work on this Idaho Batholith project. So it was cool to be able to stay on working on the Cordillera stuff. And also, actually, let me switch back to.
Look at this guy. He's out of control.
Yeah, that's
okay.
Yeah, that's better. Yeah, I was trying to be all fancy here with like the monitors and the camera and stuff. That's not really working.
It's working. It's working perfectly. Well, so yeah, your time in Pullman, you're devoted to the Idaho Batholith, and you continue that work after getting your job in Lowell. And just as a little sneak peek, Ericka, did I hear correctly that your PhD is on the Idaho Batholith or related to it somehow?
Yeah, we're just looking at some of the chemistry of the different minerals that are coming from the Batholith.
From the Idaho Batholith. Okay. Well, that's kind of, I think that'll be our challenge. Let's start with beach terrain, and I think I want to head towards the Idaho Batholith because of Rich's work, but also because Ericka's you've already done some field work for that project. So it may be a stretch, I don't know, but this is titled Gold Beach Terrain, so let's start with that. This is up for either of you to start us. Why the Gold Beach Terrain? Why was that selected as the project?
So I was looking, when I was working on other stuff, like when I was working on the Batholith and stuff, I had, seen these occasional papers coming out about like looking at other minerals besides zircon and provenance research. And I thought this was like the coolest thing. And like, why aren't more people doing this? And I guess now more people are doing it, but there's still not a lot of people that look at other minerals besides zircon. So I was basically looking for a place where you could like throw every mineral possible at a provenance study. And this turned out to be like an ideal place for that because the sediments are so immature that they have all of these other minerals. But it was Basil specifically that pointed me at Gold Beach as like a place to work on.
Okay, well, and Ericka, let's follow that thread. So I think it was you, Ericka. I tentatively called this show Gold Beach Zircons, and you very kindly said, well, I don't know if that's the best title because we're doing more than zircons, or maybe we're not looking at zircons at all. So which minerals were you looking at and sampling, Ericka, in your field area at Gold Beach?
So we were looking at, other than zircon, we were looking at monazite, rutile, titanite, and garnet.
Are those all visible in hand sample, or you don't know what you have until you're looking at a thin section or something?
Some of them you can kind of see, but basically we had to crush all these rocks up, and then you put them through this chemical that's very dense, and it sorts out all the heavy ones. So these are heavy minerals, and then we look at them in a little petri dish, and you can pick them out. If you have a lot, you can just pour them onto an epoxy mount, but I had to do a lot of picking under the microscope.
And these are sandstones generally, or what kind of lithologies are we talking about?
Yeah, sandstones mostly.
Okay. Well, I think we want to go to some of your slides in just a second, but before we do, Rich, I guess I've never had that thought till right now. Why has everybody been so locked in on zircon, and why have they generally not been doing work on other minerals?
Well, you're more likely to find zircon, like, it has like greater survivability. So there are going to be plenty of sedimentary systems where you don't have all these other minerals. But also, I think it's just because there are a lot more labs that are set up to do zircon that don't normally do these other minerals. Was probably the main thing.
So, Rich, you designed a lab that's different than these detrital zircon labs. How did you know how to set up a totally different kind of a lab?
I mean, it's the same instrument. It's just that, you're looking at different minerals. So the biggest issue is finding, good standards, because the nature of this method, the laser ablation ICP-MS method, is that you're comparing all of your sample grains to standards of the same mineral. And because there are these very large fractionations that happen during the ablation. So I hit up a lot of people that were super helpful in providing standards. I want to especially thank Chris Fisher, if you're out there somewhere, who gave me probably most of them.
Very interesting. I want to do a bunch more with you, Rich. I think for right now, I'm going to hide you in the green room. We're going to talk to Ericka, get her slides on. I don't know. Can we do this, Ericka, with all three of us? Let's try it. Yeah. Would you mind? Or one more question, Ericka, to set up the slides. So, What summer was this? A summer field season? How many days are we talking about? Were you with Rich the whole time in the Gold Beach area?
Yeah, it was just Rich and I for 4 days. I think we were out there for. And so we just drove around and hiked all day, and then when it got dark, we went back.
Yeah, this was like mid-December too. Mm-hmm. So I was expecting like the worst in terms of the weather, and it was really miserable the first day. Rain was not happy. But yeah, after that it was gorgeous. Like it was very warm the other days. But we went there then because I had to go to AGU anyway, so it was a much shorter plane ride from San Francisco to Medford than Boston to Medford.
Well, I can't hold it. I got to ask one more before we go to the slides. I don't mean to tease the slides too much here, but so you mentioned Basil tipped you off, but was it previous work decades ago that kind of was a big question mark? Like, hey man, this Gold Beach thing is weird. Like it doesn't seem to fit the rest of the Franciscan, let alone the Klamath, and somebody should really do some more work with the Gold Beach. Is it that kind of thing where you're taking some previous work and building on it? Either of you?
Well, the original people that did looked at the sedimentary, like the stratigraphy and everything, was Joanne Bourgeois and Robert Dott. So that's back in like the 80s, some of that early literature.
Yeah, well, I mean, all science is building on previous stuff.
Great point. Well, it is incestuous here. Bob Dott taught me historical geology at the University of Wisconsin in 1984, and I have fond memories of him. And I did see his name on some of these papers, which made me feel all warm and fuzzy. And Jody's been at University of Washington for a long time. So That's great that we're coming in with a new technique to build on work that they were doing back in the 80s or even earlier. Maybe Bob Dock goes back to the late 50s, I think, with some of his work originally. Okay, that's enough. Let's get us to the slides. Ericka, I'm bringing you in. Okay, nice job. I see our 3 heads plus your full slide. Are you guys seeing that as well?
Yeah, we're good.
Okay, good. Well, please give us a little introduction to this beautiful area, Ericka, if you wouldn't mind. And Rich, feel free to jump in whenever.
Yeah, so I figured I would just start off showing you some pictures because it's a really cool spot. It's all of these cliffs and sea stacks. So pretty much all of the sea stacks are the basal unit in the Gold Beach terrain, the Otter Point. And it's all these like really dark sandstones and conglomerates. And then, so Otter Point also has these tilted beds. So you can see actually in the Google Earth image here, you can really see them nicely, that these are near vertical. And then on top of it are these flat-lying Miocene and younger sediments.
Excellent.
And then this is a cliffside in the northern Gold Beach where you actually get some of your nice green serpentinite rocks here. And that's further south this way, but there's all these really beautiful folds in these cliff sides.
So there is some serpentinite in the Gold Beach?
Yeah. Along some of the fault contacts, there's some serpentinite.
Okay.
And then this is back down towards the southern and central part of the terrain, and you see these folds again in these beds here. And this is the youngest unit in the Gold Beach terrain.
Beautiful.
Yeah, it's got all these cool burrows.
Wow.
This is the Cape Sebastian unit. So this is supposed to be like a near shore environment for the deposition. And you could see the ripples really well. You can see the cross-bedded sandstone really well. And there was shelly fossils coming out of this unit as well.
Well, I got to interrupt for just a second. First of all, I'm loving this. Second of all, I'm going to hide this for just a sec. I don't know what I had in my mind for the Franciscan complex, but I don't think it was these slides I was just looking at. Like,
yeah, the Gold Beach is actually quite different than the Franciscan. Yeah. The Franciscan has all kinds of evidence of subduction, and Gold Beach does not have the right minerals for evidence of subduction.
Yeah, and I mean, the Franciscan, I mean, it has, all these, it has like these blocks of blue schist and eclogite in it, and it has a lot more like cherty and deep water sediments, sedimentary rocks, as opposed to this more sort of beach proximity type stuff.
Has the Gold Beach terrain historically been mapped as part of the Franciscan, or did I just blow that and it's not part of the Franciscan?
I think people were pretty early on saying that it was just pretty distinct. And that was, not just based on, based on like the petrography of just the seds, like, like quartz feldspar, lithic content, that kind of stuff. It looks way different than the Franciscan unit that's like right next to it, but in fault contact. So that's the Dothan Formation. Okay. So like that whole coastal area, it's like a series of these skinny panels separated by faults. Most of the faults are interpreted to be thrust faults, but the one that separates Gold Beach from the Franciscan is actually like it's vertical and it is probably strike slip, but it's very poorly exposed. Generally, it's like this is like the joke with field geology is that the fault is always where the bushes are.
Oh, this is the poison oak place.
Yeah,
that's what I'm talking about. Okay.
Bushes and poison oak.
Well, viewers, we're building towards something, whether you know it or not. And I don't want to jump the gun on some of the major kind of excitement from this unit, but let's go back to the slides, Ericka. I don't know how many more you have, but I'm loving what you have for us. Thank you.
Just a couple. So actually, Rich, you took a field trip into the Klamath, so I just put a few pictures there to kind of show the difference. If you want to explain those.
Yeah, so I mean the Klamath's it's a very wild area. There aren't a lot of roads. It's heavily forested. It's not like a lot of well, I mean, I think there are some areas with like nice jagged peaks and stuff, but a lot of it is more kind of rolling. I mean, I was telling Ericka, it almost reminds me of like the Southern Appalachians. It's just that the mountains are taller and the canyons are deeper.
Interesting.
But it's like just a geologic nightmare. That, there are all these different terrains kind of jumbled together.
Well, Rich, you can pass on this if you want, but like, what do you think of what I was doing in the chalkboard? Like, does it make sense to you to connect Blue Mountains to Klamath to Sierra foothills? Is that a crazy thing to do at this point? Or is that just an old idea? Or where are we with regional correlations of that nightmare of a place you call the Klamath?
I'll preface this by saying that I am not an expert on the Klamath, but
yeah.
I think you have to like work on it for decades to actually understand it, even at the most basic level. But my sense is that the correlation with the Sierra and the Northern Sierras is actually quite good and pretty clear cut. But I think it's less so with the Blue Mountains. For one thing, the Klamath's like there's like an eastern half of it that's significantly older. It's like some of the rocks there are lower Paleozoic. You don't get any of that in the Blue Mountains. Like everything is kind of Permian and younger. Mostly it's like Jurassic and like Triassic rocks. And I mean, so those units may match up with some of the units in the Klamaths, but I think it's much more. It's a much trickier set of matches to try to do.
Well, that makes sense to me. Thank you for that answer, because I think I'm getting that consistently. Like, there may be some correlations, but it's very difficult to say for sure. And so I keep just wondering, and I guess I'll just continue to wonder. But for our story, the Gold Beach terrain is clearly not. Can you both agree that the Gold Beach terrain is distinctly different from the rest of the Franciscan, or the Franciscan, let's just say it that way, and also distinctly different from the Klamath? There's no way to make beautiful ties, and that's the point of your work.
Yes.
Exactly.
Yeah.
Okay. All right. Well, let's go back. I see him. Please, Rich. Yeah.
Yeah. So one other thing about the Blue Mountains is that, like, I don't know that it's even necessarily clear cut that all of the Blue Mountains is intermontane. So like there are essentially like two arc terrains and then a sandwich of stuff between them in the Blue Mountains. The Old Ferry and I guess the Baker terrain, which is the sandwich between, or I don't know, the meat, I guess. If the reds are the arcs and then the accretionary complex is the meat and spread. But the outer of the two arcs, I think there are people that would debate and argue that maybe that is part of the insular too. So it's not like 100% that the whole thing is intermontane. At least that's the sense I get of it. But again, it's not. Those aren't rocks I work on like directly.
Good. Appreciate that detour. Okay, Ericka, you've got a map I can see. Let's take us to kind of the next step here in our thinking. This is exactly where I wanted to go. So thank you very much. Please proceed.
Yeah, so we have like three main pieces of evidence that would support a translation scenario. So in the Gold Beach terrain, there's late Cretaceous zircon and titanite in the late Cretaceous units. So if Gold Beach was in its present position, well, first off, the Klamaths don't have any rocks that are that age.
Thank you.
And if Gold Beach was in southwestern Oregon for its existence, the Klamath Mountains would have blocked any sediment coming from the Sierras, which does have rocks of that age. So in order to have late Cretaceous zircon and titanite, it would have had to have been south, because it's on the complete western side of the Klamaths here. It's the most outboard terrain in southwestern Oregon. Also, the sandstones themselves are extremely immature, which we kind of talked about. The variety of minerals that you see, and then even the shapes of the grains, they're all very angular, so they didn't travel very far. They have to have local sources. And the geology themselves is different. Gold Beach is rather unmetamorphosed, except for the basement unit, which has some very, very low grade alteration. And the Klamath Mountains has green schist, blue schist, and philbolite. So it's completely different. So to give you a better sort of zoomed in illustration here, the different terrains, Gold Beach is this gold one right here. And then there's that sort of vertical fault here, the whalehead fault zone that separates it from the other terrains. So the Klamath, we actually sampled the nearby terrains, the Yalabali, which is part of the Franciscan, we sampled, and then the Western Klamath terrain is in green. It's one of the subterranes there. So I just wanted to show the ages of the different minerals from the different terrains, kind of to highlight that even the ages of what we see are different. So Gold Beach primarily has Jurassic and then late Cretaceous ages. Mm-hmm. If you look at the Klamaths have some Permian rutile that we don't see in the Gold Beach. Also, like they didn't have the variety of minerals that we found in Gold Beach sandstones. It was pretty much just zircon and rutile. In sandstones from one of those Franciscan units, we have this early Cretaceous population of rutile. There's only a few of them, but there's more Cretaceous minerals than there are Jurassic minerals. So those are kind of the primary differences there.
Hey, can I interrupt for a sec?
Yeah, please do.
Number one, you're doing a great job. You're just a natural, so thank you for that. Couple of clarifying questions. I'm starting to lose it just a touch.
Yes.
So the Gold Beach is that narrow little sliver on the map on the left.
Yes.
The blue, the purple, and the green, those are subunits within the Franciscan complex. That's not the Klamath stuff, right? That's the Franciscan?
The blue, and then maybe part of this purple here. Those are Franciscan related terrains. Okay. And then this green one is part of the Klamaths.
Okay, thank you. Next question. It's been a while since we were talking about the Nanaimo group, and I don't want to give you a huge curveball, but are we visualizing what we were trying to visualize for the Nanaimo, which is these rivers coming from the interior and depositing sand? In Nanaimo, it was a submarine canyon story. Is that what we're trying to visualize for this detrital mineral material in the Gold Beach? Are rivers bringing the sand to the Gold Beach?
Yeah, so Gold Beach is also a sort of a submarine canyon story, right along the slopes of the canyon walls, I guess. And it's actually receiving sediment from the continent on the east, and then also from an arc on the west. So you have some volcanic material coming in, especially in the basement unit. So there is evidence of something outboard, which maybe it's insular.
Okay, well, I was gonna wait, but I guess I want to do it now. And Rich, feel free. So I guess the main message I'm hearing from you guys is that the Gold Beach was originally way to the south, and that it today is a small piece of a much larger insular, which is now way to the north. Is that generally the context of this study or the result of this study?
It could be. It's getting there's a lot of stuff in Gold Beach. Like it's collecting sediment from a lot of different places.
East sources and west sources. Rich.
Yeah, I mean, I think it's pretty. The case that it was from the south, that it was probably from at least as far south as like the Mojave is pretty convincing. The question of whether there was insular outboard of it dumping stuff on it it's harder to sort of say for sure. Like the sedimentological interpretation of the basal Jurassic unit, or at least what we think is Jurassic. Yeah, that's the other thing about the bottom unit in the little beach tree and the outer point is that it's a real mess. It's not really strongly metamorphosed, but it's very deformed and it's really kind of chopped up. But like that's been interpreted as being basically between two arcs, right, Ericka?
Yeah, having been deposited in one of those back arc basins. Yeah. So you're getting
the western arc in that case could have been insular, but I mean I think that, at least from the standpoint of the sedimentology, the Cretaceous units are more sort of I think thought to be like the western margin of something with everything coming from the east, more or less.
Everything comes. Yeah. Okay. Thank you for that. Yes, this is what I was hoping you're going to show. So this is the payoff. I think, at least from my point of view, this is the payoff. Please, Ericka.
Yeah. So just to sort of give you a visualization of what we kind of see, Gold Beach it's right now it's in southwestern Oregon, but you can sort of trace its tracks all the way back down to Southern California. There's old paleomag that says, maybe it's coming from this latitude as well, off of northwestern Mexico near Baja. Our minerals and the chemistry of these minerals suggest that there's definitely evidence of the Southern Sierras. There's evidence of, northern part of Baja, some of the Mojave. And then I just showed, so I know you guys are familiar with the hafnium stuff in zircon. Yes. So this, and Robinson Cecil actually had showed some of her Coast Mountains batholith stuff. So I just wanted to put our Gold Beach data, which is this gray, kind of with some of her analyses, just to sort of show that, if insular is off the coast there, and that sediment was going into Gold Beach, it would be these really juvenile, mantle derived magmas that's forming the zircon.
Interesting.
So there is quite a bit of overlap there, especially in the late Cretaceous. Everything is kind of becoming more evolved and hitting the continent, and Gold Beach actually has some evidence that it's collecting sediment from juvenile material still.
Wow. Okay. I'm loving that. A call back to an earlier episode in our alphabet series, plus some really, I just love that image so much. While we have the image up, so my ears perked up when you said paleomag, and I think Basil mentioned Bernie Hausen did some paleomag on the Gold Beach. And off the top of his head, I think Basil said 1,500 kilometers to the south. Does that ring a bell with Bernie's work?
So I don't know. Is Bernie's work published on that, or it's just?
Well, it was the thesis by Liner. Basically is the work. I don't know that they did any subsequent work on that. But yeah, so that was never published in an actual paper. It's just a thesis. But yeah, it showed that. There was this strong evidence for it originating pretty far to the south.
And there's actually this back arc basin that opens up in the late Jurassic, kind of early, and it's not there for super long. I think it closes by the Albion, which is like 110 MA. But the basal unit of Gold Beach, there's some evidence that maybe it was part of the northern extent of that basin where it's accumulating sediments from the Mojave, from the Southern Sierras, and then, the northern part of Baja.
Okay, my mind is really going crazy at the moment in a good way. Now I'm thinking of Basil's hit and run, and if this is an insular story, we're not going to start sending this stuff north. If this is insular we're talking about, if Gold Beach is part of the insular, and I know I'm putting words in your mouth now, but that stuff's going to start leaving Mexico 85 million years ago?
Well, so this
before that.
Yeah, this basin closed in the earlier part of the Cretaceous, and then there's some movement associated with that where the Gold Beach, the basal part of the Gold Beach terrain, was probably crunched and then started to move up into this direction. So that this focused map here basically is this area here.
I see.
Yeah. So we're kind of moving along this area.
And I'm also thinking of Basil's message that before 100 million years ago, things are moving south, and then they turn around and head north. Like, is there any evidence of the Gold Beach terrain moving south in a sinistral sense, and then starting to head north? I know I'm pushing things now, but I'm excited.
I'm not a structural geologist, so I can't really say, but there's some fault contacts between. So there's a fault contact between the basal unit and the overlying Houstonian Creek unit in Gold Beach, and then there's an angular unconformity between the Houstonian and the youngest Gold Beach units. So I mean, I don't know. Maybe some of these unconformities could be movement associated.
I mean, we don't really have enough stratigraphy in terms of covering the time intervals that we would want to be able to, I think, say anything either way about what's going on in terms of if there's sinistral translation at some point earlier.
Great answers. Thank you. I mean, you guys are pros. By the way, viewers, if basal is the drinking word today, I mean, you are already in the bag because we've got a basal unit and we have a basal tick-off. So this guy's going to be like, okay.
He's in the chat right now, too.
Is
he really? Basal? Okay. Well, viewers, we're coming to you in a few minutes, and we'll go where you want to go with this story. Did either of you want to add anything else to the Gold Beach study before we maybe take a few extra minutes to transition to the Idaho batholith, just a touch? Anything else about the Gold Beach that feels like you'd like to share at the moment?
I think I said my spiel.
Yeah. You did a nice job with that thesis, and thank you for sharing it so that everybody get a chance to look at it. And I'll share with the viewers the papers that you guys have selected for this show. So thanks for that. This may be an awkward transition before we go to the viewers, but Ericka, are you going to be using some of these techniques that you were doing for your master's thesis up north in Idaho? Is there any transition with these approaches?
Yeah, so we're going to look at trace elements in monazite, zircon, and we have an undergraduate student that's looking at the titanite. So yeah, we're going to use all of our geochemical knowledge and try to look at that.
And what are the goals, or what are the major questions that you're working on? Are there sandstones near the Idaho batholith that there's rivers, and what kind of concepts are we trying to flesh out with your PhD?
So we actually collected modern river sands from Idaho, from rivers that drain the batholith itself. And we want to sort of characterize the geochemistry of the minerals that are coming from the batholith. Because Rich, your earlier research, I mean, there's a whole time transgressive thing there that you can see in the geochemistry, right?
Yeah, so like the idea is that, so like with the provenance research, another thing that people are doing more and more these days is analyzing trace element ratios in zircons to try to say something about, like, does that add more information about where the zircon and the sandstone or whatever comes from? And with the Idaho batholith, we have all this really extensive compositional data on the granites themselves. And we have a bunch of old zircons from my work that are just like sitting in the drawer. And we basically want to say how predictive are these ratios that people are using in provenance researches for, the batholith, where we actually know where those zircons came from.
Is this, would you say this PhD project is related to Baja BC? Is there some sort of translation story potentially, or this is more just like refining this approach using a known source and modern rivers?
Yeah, it's more of like a process-based set of research. Like, we're basically trying to test how well trace elements, how like to what extent they're honest indicators of sort of what's going on, versus like just these jars of incredible complexity where it's very hard to deconvolve this stuff.
Okay, well, I can't stop. Viewers, a couple more questions from me. So that paper, one of your papers that you shared, Rich, I did put for the viewers as well, the short paper that's correlating the Idaho or talking about the Idaho batholith in the grand scheme of all these coastal batholiths. And speaking of confusion, I'm still confused about the Idaho batholith. Why isn't there a bunch of good paleomag on the Idaho batholith, or is there? How similar is the Idaho batholith to the Sierra Nevada batholith after all this? Like, I was taught they were the same batholith 30 years ago, and now I'm starting to wonder. Just where does the Idaho batholith fit in your eyes with that paper, pros and cons with correlating up and down the coast?
So I guess to answer the paleomag stuff first, so you need, for like the paleomag to work, you need these good magnetic carriers, and like the big one is in igneous rocks is magnetite. So that captures a magnetic field pretty well. The other major oxide that's present in igneous rocks is ilmenite. So that's iron titanium oxide, where the iron is I think partially reduced. But anyway, so ilmenite is like not a great carrier, or comparatively bad carrier compared to magnetite. And in the Idaho batholith, like a lot of the main phases of the batholith have neither. Like they have no oxides. Like they're basically too felsic. The only mafic mineral is just biotite, and that's like 5% of the rock. It's just like all quartz and feldspar. And then in cases where you do have oxides, it's more often than not the ilmenite that is present. So there are only like these pretty marginal phases that are older in most cases that do have a good magnetic signature that they've captured, and Basil has drilled some of those with what is the guy's name? I'm blanking.
It's okay.
His paleomag guy.
Yeah.
So yeah.
So
yeah,
that was
they've been able to get rotational information, so vertical axis rotation stuff from like the sort of 90 MA units on the western edge of the batholith. And even some of those they've drilled and not being able to get anything, but they've gotten some. So that's the magnetic stuff.
Well,
and then
let me
as far
just
as like
comment on that.
What?
Go ahead.
Yeah, Paul Kelso. Yeah, there's Basil. Yeah,
there you go.
He's the PMAG guy. Anyway, so the as far as like what the batholith means in terms of its the greater Cordilleran framework is that there are phases within the Idaho batholith, particularly ones that are like between about 100 and 90 MA, that look like they're essentially a continuation of the Sierra Nevada to the south. They're the right age. They're like good I-type granites that they look like they formed in the upper crust of an arc. And so some of those are present like just east of the Western Idaho Shear Zone. And then some of them are significantly further east. And then some of them are kind of just these isolated blocks of granodiorite and tonalite that are sort of surrounded by younger Idaho batholith phases. So like when you actually go out and look at the batholith today, it's like mostly in the 70s MA in the south, and then it's mostly in like the low 60s, high 50s in the north. And those are these paraluminous granites, or they're granites that they don't have amphibole or hornblende. They sometimes have two micas, so they have muscovite, the white one, and then biotite, the black one. Some of them even have garnet as an igneous phase. That's what like carluminous means effectively. But so like I guess the point of that paper you mentioned, the 2017 paper, is that there's this older stuff that is correlative with the Sierras that's largely been kind of obliterated and shoved aside by these younger episodes that are not related to the Sierras and that are kind of their own separate thing. So, you know, the carluminous stuff, it's like mostly just the crust melting, as far as we can tell. And, you know, that's due presumably to there being a bunch of crustal thickening, you know, up to that point and earlier.
Thank you for that. I mean, I could go on forever with that. I find that fascinating that there's this, potentially the Idaho batholith had these beautiful, strong paleomag signals in that earlier stuff. And then here comes these younger plutons that are just cannibalizing everything. And you just lose the signature that we need from that batholith if we want to follow through on some of that Cretaceous stuff. I just think I love that. I just love that Idaho batholith in general. So I'm excited you guys are going to continue to work up there. Viewers, I've used enough time. Would you please hit the caps lock? Would you ask some questions, please? Ericka, Rich, both, neither, what? Jim, and I guess I'll just, unless they're specific asking one of you, I'll just kind of throw it to both of you guys. Jim wonders, how does the presence of serpentinite fit into the narrative?
Yeah, so between the basal Otter Point unit and the Housetonating Creek, which is right above it, along those fault contacts, there's some serpentinite, and that there's some papers that say maybe that's getting like squeezed up from whatever is underneath Otter Point. Maybe it's ocean crust. I'm not really sure, but that was the I read that in some paper. I can't remember which one, but
yeah, rocks
you're
like
well
that,
read.
they often occur like along major terrain boundaries. And like there are some like along the Wiz too, these random serpentinite bodies that are kind of mysterious.
Okay, thank you. Let's keep it going. Papagino asks, is the Gold Beach a transpression story?
So the basal unit, Otter Point, that would have been more of an extensional story. Because if it's deposited in a back arc basin, that's extension. But I'm not really sure, Rich.
Could you be more specific, I guess, to the questioner?
I think he's asking, or she's asking, about the symbols crashing and that the 100 million year old hit of basal hitting and also sending this stuff north 85. But that's fine. Let's keep it going. John Nash asks, is the adjacent continental shelf part of the Gold Beach terrain, or is it another terrain? And what is the Gold Beach terrain's paleomag origin latitude?
Well, the
to the left. Oh, go ahead. Sorry.
I was going to say the old paleomag, they're bringing it down to Southern California, Northern Baja, that area.
Okay, thank you.
I don't know about the present
continental shelf.
Yeah, the stuff to the west, it's a big mystery. We would like sea levels to drop maybe a bit. It would be nice, so we could actually go out and look at those rocks.
We'll get right on that.
Those are like Gold Beach terrain rocks. Yeah. The guys that mapped that area, I guess for the Oregon survey, they I think went out to some of those sea stacks to look at the rocks there. Helicopter or raft or something, who knows?
Oh, that's cool. There aren't any big conglomerates in the Gold Beach that have a western source, are there? I keep hearing that from like the Olympic Peninsula with the Eocene story. These big, like the sediment size decreases as you go east through the terrain. Have you seen enough of the Gold Beach terrain to know if there's
definitely conglomerate there. Like the basal unit has a ton of these really some boulder conglomerate, some pebble conglomerate. I'm not sure which direction though.
Yeah, I mean, like so the Cretaceous, the lowest, most Cretaceous unit, it starts with a conglomerate, and then in the lower unit that's Jurassic, the outer point, there's stuff that, well, okay, so they're good conglomerates for sure, and I think they have like lots of volcanic and also like lots of chert clasts in them. And then there are like these other areas that we've seen that are, it's not even clear if it's like a melange or something. There's this unit that we're trying to get like zircons out of.
Didn't want to give us zircons.
Like full of these like diorite clasts. And we actually found some. We were able to get titanites out of those, but they were like super low in uranium and very difficult to date. It's like a plus or minus 20 million year kind of thing. That's kind of limited utility. Plus,
Wow.
I'm not even convinced that those titanites are igneous and that they're not just like hydrothermal or something.
God, I'm
So
excited
there's some
about this.
pretty weird rocks in the outer point, especially.
Very cool. Very cool. Yeah, a couple people asking us what I'm kind of intrigued about as well. Like Regine in France asks, which magmatic arc do you think was west of Gold Beach? Like, can you just revisit why you think there's anything coming from the west? I maybe kind of missed what in the Gold Beach terrain is saying western source for sure.
Well, there's a bunch of volcanic debris in the lower units. And then based on the original sedimentology, they're saying it was deposited in a back arc basin. So if you have an extensional basin opening up, there's going to be an arc somewhere on the western side. Yeah.
Why couldn't there be an arc to the east instead? Like I'd love it to be a western arc, but how do we know where that volcanic stuff's coming from?
Well, there are sort of two issues that, well, there are two bits of evidence, but they're disconnected from one another, and they're for very differently aged units. So there's the sedimentological stuff from the Jurassic sort of basal unit, the outer point, that suggests material coming from both sides. And then for the Cretaceous, we have some of these zircons and titanites that have very high epsilon hafnium and epsilon neodymium values that they would match the coast plutonic complex.
There
the
you
question
go.
is whether you could get similar materials from like the westernmost Sierra Nevada, because the Sierra Nevada, it's isotopically zoned between this sort of more mafic oceanic rooted half, and then the eastern half has much more of a continental signature in the granites. And we certainly see that continental signature in the late Cretaceous minerals in the Gold Beach terrain as detrital minerals, but some of those grains have these higher values too for the same time interval. So
Rich,
we need to find a source for those more positive values and determine whether the Sierras are incapable of supplying that or not. And it's not. It's not I wouldn't call it an open and shut case.
Right. No, but I like that. You're loosening up now, Rich. I like it. You're just kind of, hey, man, there's no harm here. We're just like throwing some ideas around, and I like your approach there. Thank you. A few people asking about the gold. So is there gold at Gold Beach? Where's the gold coming from? Why is it called Gold Beach?
We do these heavy mineral separations to get the zircon and the other things. It's like basically a float sink test. And for both this project and also for like the Idaho river sands, like we're in areas that have had historical gold mining. So I keep like expecting one of these days to find like little gold flecks, but we've never found any.
Yeah. We're going to split it 60-40 though, if we do.
60-40.
So, the Klamaths, they have a history of gold mining, I think, just like the Sierras, the gold rush and stuff.
Nice.
So presumably, if you were to sluice the Road Beach, the Road River, you would maybe find little flakes of gold occasionally if you were persistent.
Interesting angle here I didn't anticipate. Two different people asking about Siletzia, which is a much younger story, of course, but does Siletzia hit the Gold Beach terrain?
I think Gold Beach is further south. Yeah.
Yeah,
far.
so you would get into Silesia if you keep going north, and like the Gold Beach terrain, it essentially pinches out, or at least there's it pinches out, or it goes off into the ocean north of the northernmost exposure. So it's not even something we can really evaluate. It's not really clear if it extends far north enough, like, and it is just covered up under the water to have been squashed by the Silesia when it hit.
I mean, it is kind of a weird coincidence. The northernmost exposure of Gold Beach is pretty much the southernmost exposure of Silesia. Maybe I'm going down a road that's not reasonable, but yeah, like why wouldn't there be
down?
Got
We
it.
need
Yeah.
to down.
Yes, we do. How about three more, and then I'm going to say goodbye. You guys are just doing an excellent job. I'm really enjoying myself. Thank you.
Oh, we're not in a hurry.
Yeah.
Oh, okay. Okay. Pat Miller asks, is there evidence that the vertical fault separating the Gold Beach terrain extends north?
I think in the map they have it kind of going off into the ocean.
That's convenient.
So once again, we don't know. Anybody scuba dive?
David kind of asking the same thing. Are there any correlations of the Gold Beach terrain to the north, Vancouver Island maybe, or something like that? So just generally, I'm not even, there's no correlation.
It's a weirdo terrain. Like when I was comparing it to like the geochemistry of it to all of these other areas, I mean, it's so different than a lot of other places. It's like a jumbled mix.
Mm-hmm.
Should have like a Nanaimo exchange group where like we get to go up there and look at those rocks, and those folks get to go to Gold Beach.
Yeah.
Love it. A couple more. David Newton says, what decay series are used for the other mineral analyses?
It's all uranium lead. So, you know about zircon, which absorbs uranium when it forms. Monazite is actually it's like borderline on what you would consider radioactively hot. It has really a lot of thorium in it, like tens of thousands to maybe even hundreds of thousands of parts per million versus like 100 for uranium and zircon. So monazite has a lot of thorium in it, and it also has a fair amount of uranium, although not quite as much. So with monazite, we can actually use the thorium scheme, which decays into a different lead isotope, to date it that way too. And then the other ones are just ones, rutile and titanite. They just take in uranium like zircon and a little bit of thorium. Rutile is kind of the most difficult one because it often does not have much uranium in it. Some of the rutiles we've encountered are like just undatable because there's nothing there to decay, or there's so little that you can't really pick it out from the common lead that's just in like the machine gases and stuff.
So I'm guessing you guys are both in the lab a fair amount, or Ericka is now like fully trained up on everything and she's in there way more than Rich is? Or what's the just general scene in the department as far as your roles and all the analytical equipment?
I'm still learning how to use the ICP-MS, but it's been getting better.
Good.
Yeah, I mean, I like to run stuff, so I mean, I like to stay hands-on with that stuff.
A lot of times we're just sitting there together, chatting and ablating.
Well, maybe that's the last question for both of you, and mostly it's to Rich, and you can embarrass Ericka a little bit if you like, but Rich, you must have other students. So what did you see in Ericka to encourage her to do the master's and then continue with you as a PhD? You must have other students, or is it just you and Ericka that are doing most of this collaboration?
So I had a bunch of students that graduated last spring. They're all working on different projects, though. So this project is something I never had a grant for this one. It was just something that we were kind of doing for fun. Ericka came to me. Another faculty member, I think, pointed her in my direction in terms of doing research when she was a bachelor student. But I had her in class and knew she was really great, and felt very lucky when she approached me about working with me.
And Ericka, did you have thoughts of leaving Lowell and doing a PhD elsewhere, or you have other reasons that you want to stick in your town?
Well, I love the research that we do, first off. Like, I find it absolutely fascinating. And I am a little bit restricted in where I can go just because my kids are here. But I don't need to leave because I think, right now, at least, the research that we do is super stimulating, and we do a bunch of different projects and look at a variety of minerals and techniques. So it's kind of cool that Rich has such a varied background.
Excellent.
Yeah, my research I kind of have like split personalities with that stuff. I've got like this whole other set of projects that are just like completely alien to this kind of tectonics work, like looking at like metal isotopes and how they get cycled in like the deep earth and stuff.
Well, you have that stuff, but this work with Ericka and
this stuff is how I keep grounded.
There you go. There you go. But you got one foot out here, and I hope that continues with Ericka and beyond. And Ericka, I hope you continue to do work out here as well. Like, it's just always, I think it's surprising to some just people who live out here going, what the hell? What, these people are from other countries coming to study here, or Massachusetts? They just can't believe it. And there's a lot of interesting problems out here. So at least part of what's going on with you guys is it's just great to see that work continue. So I want to thank you guys both for your time today, and hope you continue to watch the series and chime in down the road. So thank you both, the both of you.
Thank you.
Thank you, Nick. Thank you.
All right, you guys. All right. Well, you have a good day. Thank you. And I'll kick Rich off first here. Goodbye, Rich.
See ya.
Oh, and Rich's fan on his computer finally goes away. We got a nice quiet sound here. So you did a great job, Ericka. You're an inspiration to a lot of our viewers, I'm sure, being a returning student and having kids in the middle of all the rest of this. So it was a pleasure to meet you, and thanks again for joining us today.
Thank you so much. Have a great day.
You too. Bye-bye. Did I kick you out? Wait a minute. Hang on. Let's try this again. Okay. Well, that was pleasant. Really enjoyed that. So that's maybe the most pure form of what I'm trying to do here, where I don't know much. And I struggle and try to do a couple of things. We go to people who've been thinking about it. They nudge in a certain direction. They expose a couple other avenues of discussion, and we just go for it. And that's why I enjoyed that one so much. I mean, come on, man. So yeah, I guess the Franciscan is not really part of this Gold Beach story, and that's the point from this work. And did I make any progress with visually or mentally swinging things through? I'm not sure I did, but I continue to get that message. Like, you got to be careful. It's not that straightforward, and that's totally fine with me. We go to the laptop. If you have a few extra minutes, I want to show you the papers that are assigned to today. And I did grab some of the images. You know, I leaned heavily for this episode on these two books. Marley Miller, second edition of Roadside of Oregon, and then a couple years later, a new roadside edition of Northern and Central California by Alton Hinman, the guys that started the roadside series back in Montana 50 years ago. And you're like, oh, come on, you're a geologist and you're using these things? Yeah, I'm using these things. These things work perfectly for me if I'm trying to get up and running with some basic messages. And there's plenty of excellent detail in these books as well. So screw you if you're a snobby academic. This is the place to go, at least to get started with some of these things. Weird attitude there. I don't know where that came from. All right, let's go to the laptop, nickzentner.com, as you're well aware. We click on the word Baja in the upper right-hand corner. And here is what we have for today's episode. This is Ericka's master's thesis. Official May of 2022. And yes, Basil Tikoff was on the committee. Here's one of many Idaho Batholith papers by Rich Gaschnig. And I was fond of this one because it took the majority of, how do I say it? It took the highlights maybe of Rich's work over the last decade and a half with the Idaho Batholith and then plugged it into a more regional story and looking at coastal magmatism, coastal plutonic activity from BC down to the Peninsula Ranges batholith in Mexico. So you might enjoy that paper. Rich and Ericka suggested I include this, which is a pretty new paper by Todd Lamaskin and others. I don't know Todd. And this is, as I understand it, as I read it, a crucial, this is the phrase of Darrell Cowan 25 years ago, a crucial test. But this paper is a specific reply to Karin Siglock and Mitch Mahalanuk's paper talking about a proposed suture. You can see, man, this is a brand new paper on the Klamath, and here they are swinging this thing through. So you can see my confusion, can't you? But this is the Lamaskin paper saying, I'm hearing all this westward subduction business from Karin and Mitch, and I'm not sure I see detail in the Klamath to support that. And if you want more from me on that, I haven't read the paper carefully yet. Just kind of a process paper, as I understand it, including Ericka's blue Sharpie pen here highlighting things. This is Ericka's copy about dealing with the detrital material and the uranium lead. And then finally, going back into the olden days, USGS folks summarizing the terrain complications. And yes, we're dealing with the Gold Beach terrain today. Looks like they named the potential Baja BC fault the Whitehead Fault Zone. So that's from the website, but I did take some time to grab a bunch of images and maps. And so I'm just kind of doing this to share as I was trying to put this story together. So early on, as I mentioned 3 days ago, I'm like, okay, time to dig in on the Klamath until I read far enough into the Ericka's thesis to go, oh shit, I guess we're not talking about the Klamath. Here's the incredibly complicated Klamath story. Again, Gold Beach, and the Gold Beach terrain is out here in the beige. From the Lamaskin paper, say, yeah, Mitch and Karin propose a suture right in here between the eastern and the western Hay Fork terrain. And I think the Lamaskin paper says, I don't think so. Back to a more basic message of the Franciscan being an accretionary wedge with an eastward subducting Farallon plate. That obviously has been questioned this whole series, at least a long-lived eastward subducting Farallon plate. And here are just some general maps from the roadside books, just showing us that this Franciscan subduction complex is, shockingly to me, continuing up into Oregon. I just didn't have that. Lamaskin showing that as well. Okay, well, here's another, I guess, after talking to our guest today. Are we losing the Franciscan and the Gold Beach because we're entering the Columbia embayment? And didn't Basil say the Columbia embayment's there because of intermontane and insular leaving the country? Shit, man, isn't this insular that's left over and the rest of insular's up in Canada and this whole is the Columbia? Okay. Just some detailed roadside maps showing if you drive California 299, you're going through all these exotic, what did Rich say? A nightmare? And then green, different shades of green are the Franciscan near Humboldt State University. Crescent City, Franciscan. Cross section, Crescent City. Hell of a lot of Franciscan. Is it truly underplating the Klamath? If it is, that's a surprise to me. And then finally, to the topic of today, this little sliver here, just this little sliver out here is the Gold Beach terrain. And I guess I assumed it was part of the Franciscan because it was colored the same as everything else in these roadside books. Oh, but now, yeah, and again, Gold Beach, Cape Blanco, Gold Beach terrain, if you know this area. I've only been down there once or twice with Liz. And okay, we're dealing with the most simple, basic tectonic story of an eastward subducting Farallon plate, and everybody's happy and everybody goes home with a smile on their face. But we are wondering openly this winter about how valuable that is with these alternative models. Maps from Ericka and her thesis. Again, look at how this Columbia embayment just is. It's one way to just, I'm looking at this white differently, I have to say. I've looked at this white most of the time to this point as just it's white because it's covered up in the German chocolate cake and the Cascade lavas. Now I think I'm seeing the white differently. I'm thinking that Columbia embayment is a way more significant part of the story than I realized before. And again, the northern edge of the Gold Beach terrain is, I'll let that map speak for itself. Ericka taking us to specific beaches. This is all in the thesis if you want to drill down, if you know and love the Southern Oregon coast. Her sampling sites with Rich as they're driving their rental car in the rain. Okay, we get it. Also from Ericka now helping us see that the Gold Beach is a distinct unit compared to the other terrains within the Franciscan and even in the Western Klamath. And this is the money shot, where Gold Beach terrain today, Gold Beach terrain 70 million years ago, Gold Beach terrain 80 million years ago, Gold Beach terrain more than 100 million years ago, Gold Beach terrain 150 million years ago, potentially in this extensional basin down in Mexico. I'm pausing because I'm remembering our previous guest mentioning that the Klamath and the Sierra were together until 140 million years ago, and the Klamath rifted out to sea. Is that all right? Okay, got it. That's probably enough. Oh, just a little bit with the Idaho batholith, since we tacked that on right at the end. So now suddenly we're up into the state of Idaho. I know that's a bit of a reach and kind of an awkward transition for us, but maybe not, because again, if we're talking about the future of Ericka and Rich working together, and we are, then they are working with the rich detail that Rich Gaschnig, no pun intended, has, maybe it was, have mapped out. This is Rich's work with incredible 1, 2, 3, 4, 5, 6, 7 separate generations of plutonic activity within the Idaho batholith. Instead of one big blob from the Cretaceous, we have earliest evidence of plutonic activity in the Idaho batholith older than Basil Tikoff's hit, where stuff is supposedly going south along the west coast. And the main point of the paper is that these younger batches of magmatic activity just obliterated this really interesting old stuff. There's just not much of it left. It was cannibalized by the younger stuff. Here's Hildebrand giving us some colors to show the same thing. Idaho lobe of the Idaho batholith, Bitterroot lobe of the Idaho batholith. This is from the Rich Gaschnig paper that waits for you at nickzentner.com. Secure. All right. Couple of scheduling notes, and then we'll do a toast to you. Thanks so much for joining us today. Session V is in the books, and we are down to the final 4 episodes. I will see you next Wednesday afternoon at 2 p.m. Pacific for Session W. Who will be the guest? It'll be Joanne Nelson, who is today living in Victoria, British Columbia. And I met Joanne for the first time the other day as we were testing the technology, and she is fun. I had a great time chatting with her. So I have all sorts of reasons to think that you're going to have a good time learning from Joanne Nelson as we go back up to British Columbia and possibly Yukon and possibly Alberta geology. We'll go back up to those concepts in the next show. And then a week from this morning, Chris Mattinson, who grew up in California, son of Jim Mattinson, very well-known geologist. Still not sure what we're going to do with Chris, but he's been watching these episodes, and we may lean into the idea that Chris Mattinson was kind of taught the California way, the California bedrock geology way of thinking, the conventional story, in other words. And he's becoming more and more interested in these shows that are basically getting away from the flat slab subduction story. Whether he totally buys it or not, I guess we'll learn together, but he's sufficiently interested, Chris Mattinson I'm talking about, interested in all these guests and these papers and concepts that, for all I know, next Saturday we'll just start with Chris and say, well, what are your thoughts? I think Chris will just go as he's been doing with me in the hallway here. As it's been just so great that he's been watching these. A toast to you. Thank you for joining us today for a session on the Gold Beach terrane. I had to look for some reason. Here's to you. Here's to your health, the health of your parents, the health of your grandparents, the health of your children, the health of your grandchildren, nieces and nephews, and everyone else in your community, by blood or not by blood. What's up, blood? What's up, Holmes? Here's to you. Weird. Here's to Ericka Boudreau, graduate student at the University of Massachusetts Lowell. You did a great job, Ericka. Thank you. Here's to geology professor at University of Massachusetts Lowell, Rich Gaschnig. Rich, you did a great job today. Thank you for joining us. I don't know if it's dawned on you, but for many of these guests, I didn't know them ahead of time. And I started emailing people last July. And I said, my name is Nick Zentner, and I teach at a college here, and I'm doing this series, and here's a couple of examples of what I'm doing, and would you be interested in being part of this Baja BC series? And some said, thanks, but no thanks. And that was the end. Others said no. And then I tried again, and I tried again, and they finally kind of like, oh, okay, I guess I can do this. A couple of the guests emailed me out of the blue, and Ericka was one of those. I think more than a year ago. She said, I'm watching your show. I like this year. I like what you're doing. And if you're interested in talking about the Gold Beach terrain, I think I'm your gal. And that was before she finished her master's thesis. So special thanks to Ericka, who volunteered herself essentially and got me going in that direction, and thoroughly enjoyed that. That's enough for today. Please go out and enjoy the weather. If you have weather to enjoy, wherever you happen to be, I thank you, I love you, and goodbye from Ellensburg, Washington, USA. It's time to go outside and enjoy the weather with Liz tomorrow morning. TMI. Goodbye.